Now let us understand what is valency. Students, we have learnt earlier that atoms combine with each other to form molecules. But how do they combine? How can we know the number of the atoms of an element that will combine with one atom of another element? This is determined with the help of the valency. So valency is defined as a measure of the combining capacity of the element. Or you can say valency is the number of the electrons an atom can donate or accept. Valency is the number of the electrons an atom can give or gain the electrons. Valency is always a whole number. It is not a fraction or a decimal, and valency of elements ranges from 0 to 4. So 4 is the maximum valency of the elements and 0 is the minimum valency. As we have studied before, electrons in the outermost shells are known as valence electrons, or you can say electrons in the valence shell are termed as valence electrons. So the loss or gain of electrons in an atom depends upon the electron or the electrons present in the outermost shell. Or we can say the loss or gain of the electrons in an atom depends upon the valence electrons. By the definition of valency, valency is the measure of the combining capacity of an element. So let's check with an example. A molecule of hydrogen chloride. Now this molecule of hydrogen chloride is written as HCl. HCl is the chemical formula or the molecular formula. Over here, one atom of chlorine combines with one hydrogen atom. So the combining capacity of the chlorine is 1. So its valency is 1. Similarly, the combining capacity of hydrogen is also 1. So valency of hydrogen is 1. Students, how will you going to define electrically neutral atom? Neutral word means no charge, okay? Zero charge on the atom. Neither a positive charge nor a negative charge on the atom, okay? For example, if I write sodium atom, this is an atom, okay? Sodium atom, because there is no charge on this sodium atom. I have not written here positive, okay? It is not carrying any charge. So this is a neutral atom, okay? It means an atom which contains an equal number of electrons and the protons. It means the negative charge will be equal to the positive charge of the atom. As we know, neutron has no electrical charge on it. Neutron is neutral, okay? Neutron carries no charge on it. So we can say number of electrons equals to number of the protons. Positive charge and the negative charges in the atom, they balance each other, they cancel out each other, and it makes an atom neutral in nature. So when a neutral atom enters into a chemical reaction, it loses its neutral nature and becomes an ion because of the loss or gain of the electrons to become stable. It means a neutral atom loses or gains the electrons and becomes stable, and the neutral atom then changes to an ion. So what is an ion? An ion is a positively or a negatively charged atom. Means atom which is carrying either a positive charge on it or a negative charge on it. Or it can be the group of atoms which are formed by the loss or the gain of the electron or the electrons by an atom or group of the atoms. So we can say an ion is an atom which carries a charge on it, either a positive charge or a negative charge. Hence, we can categorize the ion into the two categories, positive ion and negative ion. Positive ion carries a positive charge on it. Hence, it is known as a cation, or you can say it's a positive radical. For example, if I write here Na positive. Now, this is an ion, or we can say it is a positive ion carrying a positive charge, or we can say it is a cation, sodium cation, or we can say it's a sodium radical. Second category is a negative ion, which is known as anion or a negative radical. For example, chloride, Cl single negative. Because of the negative charge, they are the negative radicals, or you can say anion or a negative ion, chloride anion, you can say. Okay? So, when does the atom become stable? Atoms become stable when they have 8 electrons in their outermost orbit. Please remember, when the atom gets 8 electrons in their valence shell or the outermost orbit, they become stable. So, to attain the stability, or you can say to get the stability, means to get the 8 electrons in their outermost shell, atoms with 1, 2 or 3 electrons in their valence shell lose these electron or the electrons and gets a positive charge, and they become stable. Okay, positive ion is also known as a cation. So let's understand with the help of an example. The atom is converting into an ion. Okay, the atom converts into a positive ion or a positive radical, or you can say cation. Okay, so this is a neutral atom. Why is it neutral? Because it carries neither a positive charge on it nor a negative charge on it. So sodium atom is a neutral atom. First of all, what is the atomic number? Atomic number of sodium is 11. You have to remember it, okay? Second, after getting the atomic number, you need to find its electronic configuration. The electronic configuration, as we have done it earlier, it is 2, 8, 1. 2 electrons in K shell, 8 electrons in L shell, and 1 electron in the M shell. So, is this atom a stable atom? No, because in the outermost shell, in the valence shell, it is carrying 1 electron. But to attain the stability, atoms should have 8 electrons in their outermost orbit. So, to make 8 electrons in the outermost orbit, so this 1 electron will be lost from the sodium atom. So, Na minus 1 electron, it becomes Na single positive. How many lost? Only 1 electron has been lost. So, only 1 positive charge will be shown. Now, the electronic configuration becomes 2, 8. Earlier it was 2, 8, 1. But after losing 1 electron from the outermost shell, it becomes 2, 8. And 1 positive charge will come. Now look at this atomic number 11 of the sodium atom. It means it's a neutral atom, means number of the protons will be 11, number of electrons also will be 11. Hence it is not carrying any charge, it is a neutral atom of sodium. Now after losing 1 electron, the electronic configuration becomes 2, 8. But the atomic number will remain the same of the element, that is 11. Atomic number will never going to change. Okay, so atomic number is 11 only. And how many positive charge? 11 positive charges there. And how many negative charges now? They are not 11. Now electrons becomes 10. Why? Because one electron has been lost from the sodium atom. So 11 minus 1 electron, how many electrons? 10 electrons are left now. That's why the positive charge has increased by 1 unit. So only one positive charge, or you can write just a single positive charge. No number in front of it. Is it clear? Atoms which are having 7, 6 or 5 electrons in their valence shell, they gain 1 electron, 2 electrons or 3 electrons in order to complete their 8 electrons in outermost shell. They form negative ions called anions. How 8 electrons they will be forming? For example, if 7 electrons are there in the outermost shell, 7 electrons plus 1 electron, it will be 8 electrons. If the atom contains 6 electrons in the valence shell, then this atom will add 2 more electrons to make the electron numbers as 8 electrons. If the atom contains 5 electrons in the valence shell, then this atom will try to gain 3 electrons and make the electron number as 8 and hence become stable. Okay. Now let us understand the conversion of chlorine atom into chloride anion. Okay. Chlorine atom is given. Its atomic number is 17. So its electronic configuration will be 287. 2 electrons in K shell, 8 electrons in L shell and 7 electrons in the M shell. Over here I have seen there are 7 electrons in the valence shell or in the outermost shell. To get 8 electrons in the outermost shell, this chlorine atom will add 1 more electron, okay, and make the electronic configuration as 288 by accepting 1 electron, and this chlorine atom will gain 1 negative charge, or you can say it becomes chloride anion. Okay, so atomic number 17 of chlorine atom, same atomic number 17 for the chloride anion. Atomic number is specific for every element. It will not going to change. Okay. So chlorine atom, atomic number 17. So 17 electrons as well as 17 protons. Hence it is a neutral atom without any charge. But over here chloride anion, it is having now, after adding 1 electron, it becomes 288. So electrons has increased by 1 unit. So 18 electrons now instead of 17, right? And 17 protons. Protons will remain the same. So if an atom gains 1 electron, it means the atom has 1 electron more than the neutral atom, okay, which implies an increase in negative charge. Due to the increase in the negative charge, the atom becomes an anion. So this is a chloride anion. Now let us understand the formation of magnesium oxide. Magnesium oxide chemical formula is MgO. So for the formation of magnesium oxide, we need magnesium atom and oxygen atom. So let's understand. Magnesium atom changing to magnesium ion, that is magnesium cation. Magnesium atomic number is 12, so its electronic configuration becomes 282. In the outermost shell, we want 8 electrons, not 2 electrons. So this magnesium atom will try to remove it 2 electrons from the valence shell and get into Mg2 positive. Okay, 2 electrons are lost, so it gets 2 positive charge and the electronic configuration becomes 2,8 now and it is stable. Atomic number remains the same. Magnesium atom 12 atomic number, over here also it's the same element, so atomic number 12. In the magnesium atom, number of protons are 12, number of electrons are 12. That's why this magnesium atom is not carrying any charge on it. But after losing the 2 valence electrons, it is getting Mg2 positive charge. Here protons will be 12 as the atomic number is 12, but the electrons will be 10. because 12 electrons minus the 2 electrons, how many electrons left? 10 electrons. So over here there will be 10 electrons. So this is known as a bi-positive charge on the magnesium atom. Bi-positive means 2 positive. Bi means 2. 2 positive charge on the magnesium atom. Let us understand the oxygen atom turning into the ionic form or the ion. Now oxygen atom atomic number is 8, which will be same for the oxide anion also, right? So in the oxygen atom, number of protons equals to number of the electrons will be equal to the atomic number, that is 8 protons and 8 electrons. Hence oxygen atom is not carrying any charge on it and it is neutral in nature. Electronic configuration, it will be 2 and 6. Okay, 2 in K shell and 6 in the L shell. So total 8 electrons are distributed in 2 shells, 2 and 6. Now this oxygen atom wants to have 8 electrons in the outermost shell, but right now it is having 6 electrons. So to make itself 8, it will try to gain 2 electrons, okay, and get a 2 negative charge, or you can say bi-negative charge, bi-negative, okay, 2 negative charge, and the electronic configuration will change from 2,6 to 2,8, and hence it is a stable configuration. Now atomic number is the same 8, but here the protons will be equal to the atomic number only, but the electron number has increased by 2 units, right? So 8 electrons plus 2 electrons, how many? 10 electrons. That's why it is getting a negative charge of 2. Okay. Now these ions, they combine together. Mg2 positive plus O2 negative. And then 2 positive and 2 negative, they cancel out, they balance each other, and then MgO is the final product. Okay. This is the formation of the magnesium oxide. Let us understand the formation of the aluminium oxide. Aluminium oxide, the molecular formula is Al2O3. In one molecule of aluminium oxide, 2 atoms of aluminium are there and 3 atoms of oxygen are there, correct? So in the aluminium oxide we have 2 elements, aluminium and oxygen. So let's study their atoms. Okay, aluminium atom turning into aluminium cation or a positive charged ion, oxygen atom turning into a negative ion, that is an oxide anion. Aluminium atom has the atomic number 13. Number of protons equals to number of the electrons. So 13 protons and 13 electrons. Hence aluminium is neutral without any charge. Its electronic configuration, these 13 electrons will be distributed in 3 shells, 2, 8, 3. K shell will have 2 electrons, L will have 8 electrons, and M will have the 3 electrons. So in the last shell, the valence shell, we have 3 valence electrons. To attain the stability, it will try to have 8 electrons in the outermost shell. So this aluminium atom will going to remove its 3 valence electrons and get into a electronic configuration of 2, 8 and become stable. So aluminium minus 3 valence electrons and aluminium getting 3 positive charge with the atomic number 13 and number of protons equals to the atomic number always. So 13 protons. But how many electrons are there now? As we can see, the total electrons in the aluminium atom were 13, but aluminium atom has lost its 3 valence electrons. So 13 minus 3 electrons, how many electrons left? Only 10 electrons are left now. We can see that there are now 13 protons and 10 electrons in the aluminium cation, right? So the positive charge is 3 units more than the negative charge. So it will carry 3 positive charge on it. Okay. Now come to the oxygen atom turning into the oxide anion. Oxygen atom, the atomic number of oxygen is 8. number of protons 8, number of the electrons also 8. Hence, it is a neutral atom without any charge on it. Now, 8 electrons will be distributed in the two shells K and L. K will have 2 electrons and L will have the 6 electrons. That's why the total comes to 8 electrons, right? This oxygen atom will try to get into a stable 8 electronic configuration by accepting 2 electrons. So by accepting the 2 electrons, it will have the electronic configuration as 2,8 now. Instead of 2,6, it becomes 2,8 and becomes stable. Atomic number remains the same. Atomic number of oxygen is 8. Number of protons will also be the same, that is equal to 8. But electrons, as we can see, this oxygen atom was having 8 electrons and accepted 2 more electrons. So 8 plus 2 electrons, how many? There are 10 electrons now. Oxide anion has 8 protons and 10 electrons. So there is increase of 2 units of electrons. So it will have O2 negative. Okay. Let us understand the overall equation. Aluminium plus oxygen will give you the aluminium oxide. So their ions are now Al3 positive and O2 negative. So aluminium cation plus oxide anion going to combine together to form the molecule of aluminium oxide. Aluminium oxide molecule will be Al2O3. Over here in the product, we can see in aluminium oxide 2 aluminium atoms are there, but over here only 1 aluminium atom changed into aluminium cation, and over here 3 oxygen atoms are there, but over here 1 oxygen atom has changed into 1 oxide ion, right? So to balance the left hand side with the right hand side, or you can say to balance the reactant side with the product side, we need to make the atoms equal on both the sides. So over here, let us make the atoms equal. 2 aluminium atoms should be there here. So I will write 2 in front of the aluminium cation, and 3 oxygen atoms should be there. So 3 in front of the oxide anion. Now, if I calculate the charge on it, it will be 2 into 3 positive, how much? 6 positive charge now, plus 3 into 2 negative, it will be 6 negative charge. Both the charges are equal, that is 6 positive and 6 negative, so they will cancel out and hence they will form a neutral molecule of aluminium oxide. There will be no charge on aluminium and oxygen then. They will just cancel out. 6 positive and 6 negative, they cancel, they balance each other, and aluminium oxide molecule will be formed, which will be neutral without any charge.